This is solutions, making sense of the aqueous world. This slideshow is going to be multiple parts as I go over topics in regard to solutions. One of the first things to note is we started with the idea of matter. We have messed with different avenues of matter. We have mixtures and pure substances. And pure substances, we have chemical elements, binary compounds, polyatomic compounds. With mixtures, you have homogeneous and you have heterogeneous colloids and composite materials. Solutions. Solutions are homogeneous, and homogeneous means that they are the same throughout. We cannot discern a difference. Heterogeneous means not the same throughout. So like Italian salad dressing, you can discern a difference there. Water is homogeneous even though it has other ions dissolved in it. A solute is the ion or the substance that is getting dissolved. The solvent is the one that is doing the dissolving, like water. Aqueous is a term that we use when we're making solutions because it tells us that you have a solute that has been dissolved by a solvent and that the water is a dissolving solvent. We talked about this as balancing equations of not recording an L when we have like copper sulfate solution, because copper sulfate solution is actually an aqueous solution because of the methodology that I used to make it. Water is considered to be the universal solvent. The degrees between the two hydrogen atoms are 104.5 degrees. You end up with a dipole moment, which means that you have a positive and negative side of your atom. And because of that, it's not really a covalent substance, even though it contains two nonmetals. It's actually a polar covalent substance because it has properties of an ionic substance, yet properties of a covalent substance. Water is very unique. It's called the universal solvent because of the fact that it does have covalent and ionic properties due to polar covalent property that enables it to dissolve virtually everything. There are very few things that are not dissolvable by water, and we'll talk about that later. Quick review. Covalent means sharing of electrons equally, generally two nonmetals. Polar covalent means I have an unequal sharing of electrons, as we saw in the slide before this with the water. Ionic means I have a bond between a cation and an anion, such as salt, sodium chloride. Physical change, the change is reversible. There is no chemical reaction. So when I take my ice cube trays and I fill them with water and I freeze them, that's a physical change. Whenever I take copper 2 sulfate and I put it in the crucible and I heat it, that's a chemical change because it's hard to reverse it. And even though we do put the water back into the crucible, it does not actually go back in the proportions it's supposed to go back into. Dipole means that it has two poles, very much like a magnet. So if you think of things being like a magnet, it'll be attracted like a magnet as well. Solubility rule, like dissolves like. So water can dissolve ionic substances because it has poles with a charge. It does not dissolve covalent substances like oil because there is no charge. There has to be a drive for it to want to go from one side to the other side. The practical application of this is detergents. So every time that your clothes get washed in detergent, you're using an application of this like dissolves like. If water could dissolve everything, we would not need detergent, but it can't. And so we use a detergent that is a long hydrocarbon, and it has a water-soluble group and a non-water-soluble group. And so because it has those two ends, those ends dissolve anything. Factors affecting solubility include agitation, energy, and crushing it. You know this. You've done this in lab multiple times. You're sitting around. You're wanting your solution to dissolve faster. You guys either throw on the Bunsen burner and give it some more energy. You grab your stirring rod and you start stirring it. Or before you even put it in there, if you have lumpy crystals, you go grab the mortar and pestle and you're over there grinding it down to get it into finer particle sizes so that your surface area increases so that it dissolves faster. So this you already know. Some more terminology. Unsaturated and saturated and supersaturated. So unsaturated means that I can put more solute into the solvent. Saturated means I've hit that max point. I can't put any more in there, guys. No more can fit. But I can get supersaturated solutions. Supersaturated solutions mean that I have more than what's normally supposed to be there, and that's where your rock candy comes from. So you push it above where it's supposed to be. You keep dissolving it, and then you slowly cool it down. And as it cools down, that sugar comes out and crystallizes onto itself. And that's why you put a cedar string in there that has a few little sugar crystals on there, and they'll start growing on that. And that's how you make your rock candy. So the biology connection here is with fatty acids. You learned in biology that you have what's called saturated and unsaturated fats. And what that means is a saturated fat is going to be able to stack upon itself. So butter is considered to be a saturated fat. It is a solid at room temperature. And that's because the molecules stack up beside each other in a nice, neat fashion. Olive oil is not. It has a slight kink in it. It's an unsaturated fat. And because it's unsaturated, you can't stack as many in there like you could with the butter. And so it's actually a liquid at room temperature. And then you can get polyunsaturated, which has more and more kinks. And that's what the picture is showing you. Don't worry about the cis double bond. Just worry about the fact that when I have an unsaturated fat, it means that I have a double bond somewhere that's causing my molecule to have a kink in it, so I can't stack them as much. And that's what she was talking about in the biology.